Hey guys, welcome to the Artist server. And if you've been following this series of the R710 build, welcome back to the R710 build part 5 of the series. Now, up until this point, I've been fixing and setting up the hardware, but I actually haven't shown you that this server boots up. So in today's video, I'm going to boot up this server. And while we're at it, I thought this would be a good time for us to examine the operating temperatures, the noise levels, and the power consumption of the R710. Alright, so before we begin here, I want to take a moment to describe our setup and how we're going to go about measuring some of the metrics. So first of all, the parameters we're going to measure today are highly dependent on the components that are in this server, as well as how one utilizes the server. And the results can vary greatly. So in order to make the information we're going to collect today a little bit more useful to you guys who are watching this video, I'm going to try to compartmentalize the factors that influence those results. Now, keep in mind still that the numbers we're going to collect today are very specific to the setup that we have here, and that includes the Xeon L5640 CPUs that we have and the H200 HBA. Now, along the lines of compartmentalization, I'm going to take measurements without any hard drives first, and then I'm going to repeat the results with hard drives. And the reason for that is because hard drives can make a significant portion of the overall power consumption and heat generation of the server. Depending on, for example, if you are using a SSD that might consume, say, 3 to 5 watts, versus an older generation 15,000 RPM SAS drive which might consume up to 18 to 20 watts, you can see that that difference can vary greatly. And on top of that, because we have 6 drive bays here, that difference gets amplified by a multiple of 6. So the hard drives can actually make a significant portion of your overall power consumption. And I want to compartmentalize that and keep that separate so that the numbers that I get without hard drives will allow you to extrapolate into an estimate for your own R710 by simply adding to that number the power consumption of the particular model of hard drive that you're using. Now, in addition to that, I also think for somebody who is not that very familiar with the server and perhaps is just shopping around and wants to get a general idea of how much power will a server like this consume when it's fully built, I'm also going to repeat those tests with 6 hard drives installed in the server. Now, additionally, I'm going to be taking measurements both at idle as well as under CPU and I/O load. Now, I know on the internet, oftentimes you're going to find people reporting numbers, especially when it comes to power consumption of a server at idle. And although that is a great number to have in terms of having a minimum baseline, it's not actually what you're going to experience unless you like to power on your servers and do nothing at all with them. But like I said earlier, the power consumption of the server is going to vary greatly and highly depend on how you use the server. So for somebody that is running a lot of virtual machines and a bunch of different workloads, the power consumption is going to be very different than, say, someone who's running this server purely as a NAS and maybe just occasionally watching a movie over Plex. So by providing measurements of both at idle as well as under load, my hope is that you guys will benefit from having both a minimum boundary as well as a maximum boundary of the range that you can expect from your R710 server. Now, another factor I want to eliminate is the power supply. So for the purposes of this video, I'm going to only connect one power supply, and that just makes it easier to measure some of the numbers. But the general overhead of running a dual redundant power supply setup is somewhere between 8 to 10 watts. So if that's your plan, is to run both power supplies in a redundant fashion, then you can simply basically add 8 or 10 watts to the numbers we're going to get today. Alright, so now as far as temperatures are concerned, I'm going to be taking measurements from the sensor data on the server. Now, as far as noise is concerned, I have this setup here where I have a decibel meter set up exactly 1 foot in front of the server, and I have my phone camera which will record the results that we get on the decibel meter. Now, for power consumption, I was originally going to use IPMI to pull the power consumption numbers off the sensors in the server, but what I found was that they're actually not accurate. Actually, they're really off. And so I did a little research to try to figure out why that was, but I really couldn't find an answer. And so instead, what I'm going to do is just kind of go old-fashioned, and we're going to take measurements of the power consumption off of my trusty kilowatt meter. So that will be located right here. Alright, so you can see that the kilowatt is currently reading somewhere between 13 and maybe 17 watts or so. And this is with the server powered off, but of course the iDRAC and BMC are being powered on right now. So that's basically the power consumption of the iDRAC and BMC of the server with the server powered off. So this is what we're going to do to measure the power consumption through the various tests that we're going to do today. Alright, so for starters, let's measure the sound level of the server as it's booting up. Now, this is not the noise level that you will expect all the time, but usually it is a little bit louder during boot up, and I want to capture that sound level as well. Once we're done getting the server booted up, we'll get on the virtual console and we'll start generating a load to take the other measurements for today. Alright guys, so here I am on the virtual console. I've got CentOS 7 Linux booted up on the R710. And the first thing I'm going to do is actually run the test for no hard drives, but with a CPU load. And the reason for that is that I don't want to measure idle right after the system's just booted up and hasn't really warmed up. So because that's not really going to be accurate. Most of the time the information that's going to be useful for you is to know what the lower bound is after the system has been running for quite some time. And so I want to actually warm up the system and put a load on the system and take the measurements for the for all the power consumption, temperature, and noise level under load first. Then I'll let the system cool off for about 15 minutes, and then we'll take the measurements for the system at idle. Okay, so let's go ahead and log in first. So let me get the IP address of this machine. Alright, so I'm going to use SSH. I'm going to open up a couple of terminals here. Well, more than a couple really, because we're going to look at multiple temperature readings. Alright, so the server is at 192.168.218. Alright, let me log into that first. Oops, got the 8.
right. Okay, and let me also just have one terminal. You know what? Let me put the virtual console down, and I'll also log in. And now the reason why I'm going to open up a fifth terminal is because I'm going to use the 4 terminals that are in the background here to monitor the CPU temperatures. Now, and I'm going to run the CPU benchmark to put a load on the system in this 5th terminal. Alright, so first thing is I want to get an idea of, so let me just kind of show you this. So this is just running sensors to look at the CPU temperatures and the the temperature sensors on the system. And so you'll see 2 groups of CPU temperature sensors. So this one I believe is probably the core temp ISA 000 is the first CPU socket, and you'll see 6 cores. They're labeled or numbered rather 0, 1, 2, 8, 9, and 10. And similarly on the second socket I have core temp ISA 0001, and the cores are labeled or numbered 0, 1, 2, 8, 9, and 10. Now these core temperatures can vary, and so I don't really want to go ahead and monitor all 12 cores. I figure that's just more info, and I don't have that many terminals, and if I make the terminals too small it's probably not going to be that meaningful. But what I'm going to do is I'm going to put a load on the server temporarily just to kind of monitor things, and let's see how these temperatures fluctuate and pick out maybe the core that gets the hottest and the core that seems to stay the coolest within that socket, and we'll monitor those, and that way we'll kind of have a high and a low threshold within that socket. Okay, so anyway, we're looking at the temperatures right here. So like as it is right now, which is the system's just idling, on socket 0 here, it looks like core 1 seems to run incredibly cooler than the other ones. I'm not really sure why that is. 19 Celsius is, considering that the other cores are in the mid-20s to 30s, this is almost 5 to 10 degrees lower than all the other cores. So that does seem like that's going to be the coolest core. As it stands right now, looks like core number 2 and 10 seem to be the warmer ones. So yeah, I don't know why this one is so much cooler than the others. Now on socket 1, so this being socket 0, I'll call this socket 1. The coolest one seems to be maybe core 2 or core 10, and the warmest is looks like core 0. Okay, so this is at least at idle. This is what it seems to look like. Now to give you an idea, I also created this spreadsheet. Let me pull this up. So basically what we're going to do today is fill in the information for the spreadsheet. So on the left hand side here, I basically have set up a table for us to fill out the measurements that we're going to take today for the system without hard drives. So this is, we're going to take temperatures, noise level, and power consumption with no hard drives and under CPU load. So this is the first one we're going to do right now. And then afterwards we're going to take the measurements with no load, with basically the system at idle, and then we'll write down the temperature, the readings in this table. The tables on the right side that are kind of highlighted in orange, this is for the system with 6 hard drives. So I have 6 7200 RPM 4 terabyte hard drives. I believe they're SATA drives. I'm going to put those in the server, and we're going to basically repeat this test but with the 6 hard drives, and I'm going to put a load on the hard drives by running IOZone, and basically we're just going to write a lot of data to it continuously for 15 minutes and or longer basically, but we'll take the measurement after at the 15-minute mark. And then we'll see, how much the system temperature rises and all that other stuff. Okay, so that's basically what we're going to do today. All right, so let me put that away for now. And I want to put a temporary load on the system just to kind of tease out which core seems to run the hottest or coolest. So let me go ahead and run sysbench. And we have 24 threads on the system, so we'll just run the whole 24. And we'll just run it for 60 seconds here. CPU run. Alright, so we'll just run this for 60 seconds and let's see how this goes. So on socket 1, it's looking like core 10 seems to be hottest. And yeah, core 1 seems to be the coolest. Okay, so yeah, I think that's what we're gonna do. So we're gonna pick core 10 as the warmest and core 1 as the coolest. So let's go ahead and record that in here. So the hottest would be core 10. And the coolest is core 1. Alright. Oops. Not 10, just 1. Okay. And then on, let's see, let's make sure the benchmark, oh, the benchmark stopped. So let me just run that again. Okay, let's look at the socket 1 here. So the warmest seems to be core 0. And the coolest, it looks like it's between core 2, 8, and 10. Yeah, definitely core 0 seems to be the warmest, so let's just go ahead and record that one. Oops. Let's get the... so the warmest is core 0. Is that what I said? Yeah. And then the coolest seems to be core 2 or 8, or maybe 10. I'm just going to go ahead and pick core 10 as the coolest one. I think it's kind of a tie between 2, 8, and 10, but I'll just pick 10. Alright. Alright, so we've got the cores that we're going to monitor picked out. And let's go ahead. Alright, let me get out of that. So I'm going to use this tool that I put together called Sensors Plotter. And if you haven't seen this, there's a video I made about this tool and kind of how to visualize sensor data in a CLI environment, and that's kind of exactly what I'm going to do today. So if you're curious about that, go check out that video. I'll put a card up in this area for you so you can check out that video. But basically, we can use this to basically collect data off the sensor's output, and also kind of give you a little bit of a plot so we can kind of visualize it a little bit. Alright, so I'm going to use that tool here. So on the left hand side, on this window and this window, I'm going to do socket 0. And the top window will be for the cooler core, and the bottom will be for the hotter core. And then on the right hand side, I'm going to basically repeat the same thing except for socket 1, or the second socket basically. Alright, so first of all, we need to get the names of the sensors. Alright, so let's go ahead and now what was it that we said? We said for the coolest core is core 1 on CPUs or socket 0. So core 1 would be this temperature sensor. Alright, so the chip is core temp ISA 000. The sensor we're going to monitor here is this one, and let's give this a title, CPU 0, core 1, temp. Okay, and we'll generate some statistics and go ahead and monitor that. Alright, so that should start collecting data on that one. And the warm core is core 10 on CPU 0. Okay, so core 10 is this sensor here. Let me copy that. Alright, so this is core temp ISA 000, and the sensor is temp 12 input. Okay, and we're going to call this CPU 0, core 10, temp generate. Alright, there we go. So, sorry about that. Mistype there. Okay, so that is monitoring CPU 0 or the first socket. Let's do the same here on the second socket. So we will do chip is core temp ISA 001, and the sensor for this is, so this is going to be the cooler one, right? So the cooler one on the second socket is core 10, and let's figure out what the sensor name is. Sensor name is basically this. So, and we'll title this CPU 1 core 10 temp and generate statistics on that. All right. Sensor plotter. Alright, so the chip is core temp ISA 001, the sensor name, and this is for the warmer core, which is core 0, and that has temp 2 input as the sensor. We'll title this CPU 1 core 0 temp and generate stats. Alright, so now you can see that we're monitoring. This is on the left hand side, the first socket, the right hand side is the second socket, the top is the cooler core, so right now we're reading about 19 or 20 Celsius, and the bottom is the warmer core, currently reading about 30 or 31, 32, and this is on the second socket, so the cooler core is reading about 24, 23 Celsius, and the warmer one is reading about 30, 31 Celsius. Alright, so now this is again under no load, and this is not really relevant right now because we want to warm up the system before we start taking measurements for idle. Alright, so now I'm going to generate a load on the system, and we're going to follow this methodology. I'm going to generate a load with 24 threads. I'm going to run it for about 20 minutes, but we're going to take measurements at the 15-minute mark. So, alright, threads 24, time is 1200, and CPU run. Okay, so as we run this benchmark, you should see the temperatures in the background basically rise, and we're going to run this for 20 minutes. Alright, let me bring the temperature charts to the foreground. So yeah, as you can see, we are seeing the temperatures rise. Here it's reading on socket 1, or the first socket, 35 up to 45 degrees, and on the second socket we are reading a 40 to 45 degrees. Alright, so the system is currently under load. I'm setting a timer for 15 minutes, and I'm going to come back to this and we'll take some measurements at that point in time. Alright guys, we're back at about the 15-minute mark here, and we've got some numbers here that I think we can record. So I'm going to go ahead and stop the charts here, and let's go ahead and record this data. So on the cooler core here, we reached a max of 47 degrees Celsius. So let's go ahead and record that. Let me bring this down a little bit. Okay, so this is on socket 0, and the cooler core had a minimum of 18 degrees Celsius, a max of 47, and the average for this run was, say, 39.90. Okay, and the warmer core, which is the one down here, we reached, well, the minimum was 31. We reached a max of 55 degrees, and the average was 49.10. Alright, so let's go ahead and also record the numbers from the warmer core, or sorry, the second socket rather. So the second socket, let's see. Yeah, so this is core 10, second socket, the cooler one. Okay, so we have a minimum 23. The max reached was 51, and average was 44.84. And then the warmer core, we got a minimum of 30, max of 55, and the average was 50.53. Alright, so now I'm going to go to the lab here and actually go measure the sound level as well as the power consumption.
Okay, so we see that the server is consuming about 234 watts at this time. This is under CPU load with no hard drives.
Alright, so at this point we're going to let the system cool down, but let's go ahead and record some of the numbers we just saw. So for noise level, it looks like it was somewhere in the ballpark about 51 decibels. And the power consumption was about 235 watts. Alright, so I'm going to let the system cool down for 15 minutes, and then we'll come back and record the idle readings. Alright, it's been about 15 minutes. Now we're back here looking at the temperatures of the CPU cores. And yeah, let me go ahead and stop the data recording. And let's go ahead and record this data for the idle temperatures. Alright, so for the coolest core on the first socket, or CPU 0, here we are monitoring core 1 and core 10 as the warmest. Let's see, the minimum was 18 degrees, max it fluctuated at idle, I guess between 18 and 22, averaged around 19.72. Alright, and then for core 10, which is the warmer core, we have a minimum of 30 degrees. Wow, that's a pretty big difference between the warmest core and the coolest one, the 12-degree difference. I don't really know what's up with that, but that's what we're seeing here. And so anyway, it fluctuated between 30 and 33 degrees, averaged at 31.79 Celsius. And let's go ahead and look at the numbers for the second socket here. So here we are monitoring core 10 for the cool core and core 0 for the warmer core. So this, we have a minimum of 23 degrees, a max reached at 27, so it fluctuated between 23 and 27, but averaged at 24.35. And for the warmer core, we're looking at a minimum of 30 degrees, max at 33, and average at 30.77. Alright, so the warmer core seems to be identical on both sockets, while the cooler core, yeah, this one is just something special. I mean, I guess it's consistently just runs a lot cooler than the other cores within that CPU, and I don't really know why, but I guess sometimes that can happen. But you know, the temperatures are close, and here it's fluctuating between 18 and 22, and this is fluctuating between 23 and 27, so for a range of roughly 4 degrees Celsius, but the average was closer to the minimum than it is the maximum, so which is not surprising since this is taken after 15 minutes of idling. Alright, so let's go ahead and go down to the lab and take some measurements for the noise level as well as the power consumption. Alright, so we see that the power is hovering around 119 to 120 watts, and this is after idling for about 15 minutes. So that seems to be the lower bound of the power consumption. Alright, so for the second part of this test, I'm going to replace these brackets, they are empty right now, with ones that actually have hard drives. So these are Hitachi 4TB drives. They are SATA drives, I believe. Let me check. Pretty sure they're SATA drives. Yep, SATA 6 gigabit. So these are 4TB SATA drives, and I'm going to replace the empty brackets with these 6 SATA drives. Alright, so we've got 6 hard drives now installed. Let's get back on the virtual console, make sure we see them. We're going to go ahead and set up a striped RAID 0 and ZFS with these 6 hard drives, and then we'll write data to them and put a load on these hard drives, basically constantly writing to them for the next 15 minutes, while we also put a load on the CPU like we did before, and then we'll take the measurements again. Alright, back at the desktop, and let's go ahead and record the numbers we just saw. So for noise level, it was basically reading around 51 decibels. So interesting thing is that basically we didn't really see much of a change. The temperatures, even when they're high, the fans really didn't spin up that much, or if they did, they didn't really. I guess I never really measured the RPMs on the fan, but it didn't really generate more noise. So I'm assuming that the fans were roughly at the same RPM. Alright, and as far as power consumption, it was basically idling at around 120 watts. Alright, so let's go ahead and put that information away for now, and let's get back on the terminal. So I've plugged in those 6 hard drives. Let's see if we see them. Alright, so we definitely have 6 hard drives here, and let's make a Z pool out of those. So in order to do that, I'm gonna Z pool status. Okay, I don't have anything right now. Let's create data, and this will just be a stripe. So let me force it just in case there might be something there. So it's B, C, D, E, F, G, and so that should do it. Alright, let's look at zpool status, and our pool is now ready. So let's create a data set. So we will create data, test, and let's make the record size here 1 meg. And that's because we're going to try to write as much data as we can to these drives as fast as we can. Alright, so we have 22 terabytes of available space, in /data/test. Now you might be wondering, well, why am I just doing like basically a RAID 0 across these 6 disks? I'm not doing any redundancy or parity, basically. Like, so I'm not doing like RAID Z1 or RAID Z2, and the reason is that I'm really just trying to generate as much load on the hard drives as possible without consuming CPU, because we're going to be putting the CPUs under load as well. So anyway, for the purposes of this test of just generating a lot of writes to the hard drives, doing a RAID 0 where I'm writing really large blocks to the entire data set across the entire 6 disks should be exactly what we need to just generate a lot of load on the hard drives. Alright, so you know what, I'm going to have to create another terminal because we're going to be running the benchmark tool for the CPU as well as for IO zone. So yeah, let's go into /data/test, and I'm going to go ahead and run this. We're going to do the sysbench. So let me set up for that. So we're going to do sysbench threads. Now I'm going to use 12 threads instead of 24 as we did last time, and that's because I'm reserving 12 for the IO zone. I'm going to run 12 threads on the IO zone benchmark. And I just don't want too much CPU contention because I want to be able to generate enough data to write to the hard drives. Okay, and again we'll just do the 20-minute run, and this will be CPU. Alright, and then for IO zone, okay, I'm in the right directory. I'm going to run IO zone. We're going to create 100 gig files, so that should keep the server fairly busy. We'll use 1 megabyte blocks. We'll do the write test, and this is a sequential write test as well as the sequential read test. We'll do it with 12 threads and a stride size of 64. Alright, so once I launch these two programs, we should generate a pretty heavy CPU load as well as a disk I/O load on the system. And then we'll let this run for 15 minutes and come back and record the readings that we get. Alright, so now before I start those, let's start collecting all the CPU data again, or the CPU temperature data. And again, we'll just use the same cores that we were monitoring earlier. So I will just basically rerun those commands and collect a new set of data for the temperatures. Alright, so if I start running the IO zone, you know what, I kind of want to see that this is actually happening, so let me open up another terminal, and that way I can look at this. So just going to monitor that and see if we are actually generating a IO load on this. Okay, yeah, so you see we are writing about 900 to a gigabyte of data, and you can see that the temperatures, let me lower that, the temperatures are going up a little bit because we're using some of the CPU for generating this IO benchmark. Now we'll load the CPU up even further with a 12-thread sysbench run, and if I switch, let's see, so it's not affecting our IO because our IO is still hovering around 900 to a gigabyte a second, so that's good. And if I look at top, we have the system fairly loaded. Yep, sysbench is keeping the system fairly busy. Alright, so let's just throw that in the background there and watch this. So yes, the temperatures are going up. So far we've seen a max of 47 degrees here. Alright, so we're going to let this run for 15 minutes and then come back and see what we get. Alright, we're back here after about 15 minutes of CPU and I/O load on this machine. And so let's go ahead and stop the data collection so we can record this. Alright, so let's look at the first socket here. And we're going to look at, basically these are the same as last time, so let me write that down first. Core 10 for that, core 1, oops, okay, core 0 for the cooler one, and core 10 for the, or that's the cooler one for core 10 on CPU 1. Okay, so let me move this over here. Okay, so the cooler one is the one up here. We measured a minimum of 20 Celsius, a max at 47, and it averaged about 39.78. And oops, sorry, that was the cooler one, right? So actually I need to put these numbers down here. 20, 47, 39.78, and let me get rid of these. Alright, and the warmer core is the one down here. So we saw a minimum of 32 and the max of 55, which is very similar to what we had last time, and 49.54. Okay, and now let's go ahead and collect the data for the second socket. And we'll start from the top here, which is the cooler core, and we have a minimum of 25, a max of 50, and an average at 44.41. And then for the hotter core, we have a minimum of 31, a max at 55, and an average at 49.55. Alright, so the interesting thing is that the warmer cores basically are almost identical, ranging from 31 or 32 up to 55 degrees, and averaging at around 49.5 degrees, while the cooler ones, again, now this CPU for whatever reason has this one core that seems to run a lot cooler. That basically ranged from 20 to about 47 and averaged around 39.78. Alright, let's go ahead and go back into the lab, and we'll take some readings on the noise level as well as the power consumption. Alright, we see that the power is actually fluctuating quite a bit, and I'm wondering if this has something to do with just the I/O load. So this is with the CPU underload as well as all 6 hard drives underload, and it's hovering somewhere between 250 up to 300 watts, and it seems to fluctuate quite a bit. And there it hit above 300 for a brief moment, and there again. So with the I/O load, it seems that the power consumption can fluctuate quite a bit. Alright, so let's go ahead and record the numbers we just saw. Basically the sound level was unchanged, and I'll just record it as 51 dBA as before. Power consumption, now that fluctuated quite a bit, and I wish I had a way to record several data points and get an average here, but instead I think I'm going to try just record the maximum that we saw, which was 306 watts. Alright, so at this point now we're going to let that machine sit idle for 15 minutes and just let it cool off, and we'll collect some temperature data and also the noise level and power consumption again after 15 minutes of letting the machine idle. Alright, we've let the system cool off for about 15 minutes now. Let's go ahead and record the readings we have here. So let me go ahead and stop the data collection, and let's pull up the spreadsheet here. Okay, let's start with the CPU 0, and the top here is the cooler core. So, oh yeah, let me go ahead and record which core it is that we are recording here. Alright, so for the cooler one, we got a minimum of 21 degrees and a max of 35. Averaging around 24.69. And for the hotter core, we have a minimum of 34, max of 44, and average of 36.14. Now between the minimum and max, it looks like there's quite a spread. There's at least 10 degrees here, and 14 degrees here. So this is probably a result of the hot run that we had where we put the whole system under load, and so I think some of the max was basically coming down from the previous load test. Alright, so let's go to the second socket here, and we have a minimum of 25, a max of 37, average of 29.00, or rather 0.01, not that that really matters. And for the hotter core, we have a minimum of 32, a max of 42, and an average of 35.33. Alright, so I'm going to go downstairs to the lab, and we'll record the sound level and the power consumption, which I don't believe the sound level is going to change much, but alright, let's go check that out. So we see an idle of about 163 watts. It's fairly steady at idle. Basically there's no disk activity, the CPUs are fairly idle, and it just hovers a little bit between 162 and 163, well, 164. So very little variance there, fairly steady. Now if you recall from earlier, the idle that we recorded without the hard drives was about 120 watts. So the 6 hard drives, the 6 Hitachi 7200 RPM SATA drives that I have in the server now, are basically adding about 43 watts to the system. Alright, so let's go ahead and record the numbers we just saw. The noise level is basically unchanged, and the power consumption was about 163 watts. Alright, so let me go ahead and let's go ahead and look at the results we've gotten so far. So basically, with the L5640 Xeon CPUs, the maximum temperature seems to be roughly around 55 degrees. Now this CPU seemed to run a little bit, oh no, sorry, this is the idle. Okay, so at idle, it's averaging somewhere around 31. I don't know, there's this one core that's like really cool, but anyway, it's fairly steady. Now I don't have a temperature reading for the room ambient temperature there. There's no cooling in that room, but it is a fairly large room, so my guess is that it's somewhere in the mid-20s, perhaps, Celsius. So, or maybe less. Yeah, I don't know. I'd have to take a reading to figure out what the ambient temperature is in that room. But anyway, you can see that basically the temperature does go up a little bit if you look at with the hard drives installed. So the average temperature at idle without hard drives, somewhere between 19 to 31-ish, and with hard drives it's about 24 to 36-ish. So it's consistently about 5 degrees warmer on average at idle with the 6 hard drives installed. Okay, and those are 7200 RPM drives, so they are a little bit warm. They're not the hottest drives by any means, but they are certainly not the coolest drives. If you get some of the 10 terabyte, 8 terabyte easy store drives, those seem to run really cool. So you could probably reduce the overall system temperature a little bit by using those type of drives. But 7200 RPM 4 terabyte drives are fairly common, and they're actually very affordable right now. So this is, I think, a good sampling to show that adding the 6 hard drives does increase the overall system temperature by roughly about 5 degrees. Now, as far as noise level goes, it really doesn't change across the board here, whether it's idle or under load, whether with hard drives or without. It really just did not change. Now, keep in mind though, in our scenario, we're using the L5640 CPUs, and so they don't get very hot. As you can see, even under load, they are basically roughly at 55 degrees Celsius or a little under. Now, I would imagine that if you had installed one of the more powerful Xeon CPUs that are available for the server, like the X5680, X5690, those processors can get much hotter, and I would suspect that under load with those processors, certainly your power consumption will be a lot higher. But in addition to that, I think the temperatures will be also higher, and in that case, the fans would probably spin up. Unfortunately, I don't have any of those faster processors to test right now, but I would imagine the fans would spin up and you would generate a little bit more noise. But with the L5640s, the system is pretty much capable of keeping the temperature under control without having to really spin up the fans and generate more noise. So that's actually kind of a cool result that we got here. And basically, that the noise level is not going to change when you're using the L5640s. Now the the power consumption without any hard drives ranges somewhere from 120 watts up to 235 watts, and this would be purely just a CPU load. Would basically add about 115 watts under load versus no load. With the setup where we have 6 hard drives installed, it varies from 163 watts up to about 306 watts. So the difference there is a little bit more, somewhere in the ballpark of about 140 watts more. And remember, this is under CPU and I/O load. So if you look at the difference between no hard drive and having 6 hard drives in the system, the difference is roughly about 43 watts, so let's just say roughly 40 watts. So the difference between the system under load is basically, let's see, that's 65, 70, yeah, 71 watts or so. So yeah, that's, obviously with the hard drives, it's going to consume more power. Under load, the hard drives are going to consume more power as well. And so at idle, the hard drives consume about 40 watts more, 43 watts more, and under load, the hard drives consume up to about 70 watts, right? So, yeah. So anyway, that's why I was saying that the hard drives can become a significant component of your overall power consumption. And these really were kind of middle of the road. The 7200 RPM SATA drives are just kind of middle of the road. Obviously, you can get more energy efficient hard drives like the 5400 RPM drives, or if you went with SSDs, obviously would consume a lot less power. But there are also the 10,000 and 15,000 RPM SAS drives that would consume a lot more power. Alright, so hopefully you guys found this useful, and this gives you an idea of the temperature range of what you can expect from R710, at least with the L5640 Xeon CPUs, which are probably my favorite option for this particular platform. And the power consumption. Hopefully that'll be useful for you, especially the ones without the hard drives. I hope that you guys can use that number and extrapolate that to your particular configuration with the hard drives that you're using to figure out roughly, how much power your system should be consuming. And the good news here is that at least with the L5640 Xeon CPUs, basically because the temperatures just never really get that hot, they kind of max out at about 55 degrees. The fans don't seem to have to spin up much to keep those systems temperature under control, and so basically the noise level is pretty much identical across the board. Alright, so anyway, that's what I've got now, and in the next part of this we will look into boot drive options. Alright, so people have asked me, well, what kind of setup do you have for booting on the R710? And there are at least a few options there, and I want to explore some of those in the next video, so stay tuned for that. And anyway, hope you liked this video. If you did, please give me a like, and be sure to subscribe to see more videos from me. Thank you very much, and have a good day. Bye-bye.